you see something like this is you want to take that term right there, x to the 2/3, and you're going to let that become your u value, or whatever variable you want to introduce. It doesn't always have to be a u. Whatever variable you want to use. But we're going to go u is equal to x to the 2/3. Okay? Now the reason I do that, now you don't have to write this, but this is the logic behind it. If I know u is equal to x to the 2/3, then u squared, well, if I square this, I get 2/3 raised to the second power, and we multiply that out, it looks like this. The x to the 2/3 raised to the second power, you have a power to a power, so that's x to the 4/3, right? Does that kind of make sense? So now we recognize that we can make this substitution. We can say that when I see this 4/3, x to the 4/3, x to the 4/3, I can now rewrite that as u squared. Okay. When I see this x to the 2/3 in my original equation, I can now rewrite that as u, so minus 15u, and then plus 56 is equal to 0. Okay. Hopefully then that's something we can factor. We're going to go u minus 8 and u minus 7 is equal to 0. So then we get u is equal to 8 and u is equal to 7. Okay? Now remember what u was. U, we said initially, was that x to the 2/3, right? So once we solve for u, and we've got an answer in regards to u, we now make that back, we call it back substituting. We put that x to 2/3 back in both those. All right. Now here's the thing: when we have that, when we solve these equations, we're trying to solve for x, right? X to the first power. Right now, they are not to the first power, so we got to think about how we can get those raised to the first power. And I think the best, and you can do this in 2 steps. I like to do it in 1 step, but I think the best thing to realize is if I've got x to the 2/3, the best way for me to get that to be first power is to raise it to 3/2. Okay? Because the definition of reciprocals says that when I multiply reciprocals together, it should be the product of 1, right? Okay? And that's what I want. I want that exponent to become 1. It's a fraction right now. So I multiply by its reciprocal, and I should get 1 there. Okay? You could initially maybe cube both sides. Okay? So I can probably do some on the whiteboard here. I could have, x to the 2/3. I could raise that to the 3rd power, so now I have x to the 6/3, right? Which is actually x squared. And then what would I have to do with that? We're going to try to solve for x. Square root. Okay? That might be maybe a little bit more explicit for some of us, but because of the next step. But this should be something that we've seen in Algebra 2. And if not, we'll deal with a lot in this class anyways. But if I raise the left-hand side to 3/2, I got to do the same thing to the right-hand side, so 8 to the 3/2. And this is kind of the Algebra 2 that we need to remind ourselves of. That's x to the first now. Okay? Now, whenever we have, it's called a rational exponent. Okay? When it's a fraction. Okay? The denominator is actually telling us the root that we're dealing with. Okay? So I'll put a 2 out in front of my root. And now the numerator is actually the exponent of the radicand. Okay? You should have seen a rule in Algebra 1 that says if I have a to the m over n, that is all the time equal to the nth root of a to the m. Okay? If you think just some, maybe some simple values of a and m and n that we could use. Say if I say 9 to the 1/2, okay? Well, I should be able to put the 2 out in front, and then 9 to the first, and we know that should evaluate to 3, right? And I could double check that to make sure that it does evaluate to 3 with my calculator. Maybe. we go 9 raised to the 1/2 power, so that's 0.5, still evaluates to 3, right? Okay, so that little bit of algebra 2 is going to be pretty helpful in this problem, because now we've got 8 to the 3rd, which I think that's 343. Yeah, 343. So now I've got the square root of 343, and remember that's plus or minus. Okay, and we can simplify that. The next thing then is we're going to do the same thing with the 7. So I'm going to raise this to the 3/2 and raise the 7 to the 3/2, so x equals 7 raised to the 3/2. So now rewriting that, that's the square root of 7 cubed. 7 cubed is 7 times 7 times 7, which I got that back. This one's 512. This is 512. This one is 343. My fault. But now it's the square root of 343 square root of 512. We can simplify now to take out the square root of 7. I get your answer after math circle. Does that kind of make sense? Okay. If you went and did it this way, which isn't, there's nothing wrong with doing it this way, but say I have x to the 2/3 is equal to 8. I could raise this to the 3rd power, raise that to the 3rd power, and I now get over here x squared, because again that's going to be 6 over 3, right? 6 over when I multiply those together, 6 over 3 goes to 2. And over here I have 8 to the 3rd power, so 8 to the 3rd power, that was the 512, right? So I have that. Now what would I do to solve for x? Square root both sides, and I get the 512, right, underneath the radical. So you can do it in 2 steps, or you can do it in 1 step, whichever one is more convenient to you. But what we're going to do eventually in this class is every time that I see a rational exponent for a variable, I'll understand how fast we can change that to a radical expression. Okay? Rational exponents are another way of writing radical expressions. Okay? Well, hopefully that helps with questions like that in regards to the U substitution. Are there any other questions that you guys want to talk about? Anything that you've seen so far on that 1.6 through 1.8 that's problematic? Remember, that's not due until Friday, so I know maybe some of us haven't really spent a whole lot of time on it. At least spend some time on it tonight so that you can ask those final questions tomorrow. I'd like to give you some, but